أعزائي الطلاب، يعطيكم العافية مطرح ما كنتوا. معكم الأستاذ حسن كوراني، رح أعلمكم مادة الرياضيات لصف علوم الحياة. مثل ما شايفين درسنا رح يكون عن Exponential Function for Life Science Section. هلا أكيد رح يستفيدوا منه باقي السكشنز، اقتصاد واجتماعي وعلوم عامة، لأنه هذا الدرس مثل ما بنعرف هو مشترك لكل هول الصفوف مع بعض التفاصيل الفروقات بين صف وصف. أول شيء خلينا نشوف الأوبجيكتيف لهذا الدرس. Study the exponential function. We will see the domain, the properties, limits, derivative and curve of the exponential function. Before we start, I would like to make a quick revision on the inverse function that will help us to understand very well this chapter, the exponential function. Revision about inverse function. Okay? As we know, a function admits an inverse if it has two main conditions, which are continuity. This function should be continuous, and also strictly monotonic. Monotonic means that it is strictly increasing or strictly decreasing. Let's write this down. A function f admits, a function f defined over an interval I admits an inverse f inverse. The notation of the inverse function is f inverse if it is continuous, as we have said, and strictly monotonic, which means strictly increasing or strictly decreasing. Increasing or decreasing. Now, as you know, if f is defined over this interval, it takes x values from here to f of I, the image of this interval. This is, as you know, the domain of f, and this is the range of f. It takes x, and this is f of x. Why? The inverse function acts in a reversed manner. It takes the inputs from f of y to y back. This is the behavior of f inverse. Okay, let's talk now about the common properties or the properties of these two functions, a function and its inverse. Properties of f and f inverse, which are very important to understand deeply the exponential function, which we will learn in this video. First property, domain of f inverse. What is the domain of f inverse? It's in fact this, as we have said, f inverse takes values from here back to I. So this is the domain of f inverse, which is the range of f. It will be f of I, where I is the domain of f. The second property is about the derivative of f inverse. It will be 1 over f prime of y, where y equal f of a certain x, and we solve it to find y. We usually know the value of x, and we are asked to find the value of y by this way, by solving this equation. As you see from this last point, the sign of f inverse prime depends on the sign of f prime. They have in fact the same sign, since if f prime is positive, then this will be positive and vice versa. Thus, f and f inverse have the same sense of variation. We can deduce easily this from the previous point. The next idea or property about f and f inverse is about the curves. The curve of f and f inverse, you should know this from previous chapters. The curve of f and f inverse, the curves of f and f inverse are symmetric with respect to y equal x, which is the first bisector known. Their curves will be symmetric with respect to y equal x. The last point is the expression, the explicit form of f inverse. What do we mean by this? As you know, this is the expression of f inverse in terms of x. And this can be easily done by solving, by put y equal f minus 1 of x, and this leads to say that x equal f of y at the end, and find y in terms of x. And once you know y in terms of x, in fact you got the expression of the f inverse. That's it. After this brief revision about the inverse function, let's talk now about the logarithmic function, which we studied before in a previous chapter. Well, after this quick revision about the inverse function, we are going to recall together the logarithmic function, which is related to the exponential function, which is the title of this chapter. We know that the logarithmic function, the Napierian logarithmic function, which is denoted by Ln, is continuous and strictly increasing over its domain, which is known 0 plus infinity. Thus, what can you deduce from this? As we have said previously, that then this function, which is continuous and strictly increasing, it will admit an inverse function. Then it admits an inverse function. Now, let me write this down. 0 plus infinity. These are the allowed values or the input values of ln. It takes them to minus infinity plus infinity, as you know from previous chapter. Ln takes x values, and these are the y values of ln. So, as we said before, yes, we have the inverse function of this function. If we call this function f of x, then the inverse of f of x will be defined over this domain and take values to range 0 plus infinity of this inverse function. This is the inverse of ln. Okay? Now, let's go back to the ln function itself. F of x equal ln x in order to deduce the properties of this function, the inverse function. F prime of x, as you know, it will be 1 over x, and as x always positive, then this will be always positive. Also, limit as x tends to 0 plus of ln of x, it is minus infinity, and also limit as x tends to plus infinity of ln x is also plus infinity. What can you deduce from this? Now we can also write down the table of variation of ln x and this is the domain. This is the domain, the input values of x. As you see, ln x derivative is positive, and this means that the function is increasing over 0 plus infinity, and this is minus infinity. And as you know, this is what? This is the vertical asymptote for the curve of ln x. Now, from all of these informations that we have, we can deduce the properties of its inverse. Then, first property, the domain of f inverse. Domain of f inverse is f of I. We said before I, but here we have I is 0 plus infinity. So f of 0 plus infinity, but as f is increasing, be aware about this idea. If f is increasing, then the image of this interval will be limit as x tends to 0 plus of f of x, limit as x tends to plus infinity f of x also. While if we have a function which is decreasing, then we have to reverse these bounds. Then we get at the end the domain of this inverse function, as we calculated before. It will be minus infinity plus infinity interval. This is the domain of f inverse. Now, till now, we knew the domain of the inverse function. The second point is the limit of f inverse of x as x tends to minus infinity. It will be what? As you see, as we know, inverse function acts in a reversed way. F takes values from this interval to that interval, while f inverse takes the values from this interval to that interval. From this, we can deduce that limit as x tends to minus infinity of f inverse, f takes values from here over there. The limit as x tends to minus infinity of f inverse will be what? Yes, 0 plus. And limit as x tends to plus infinity of f inverse will be what? Also plus infinity. Now, what about the table of variation of f inverse? Here we have f inverse of x. It's stable. No need to put the derivative in this case, since we know the variation of this inverse, this function. Its domain from minus infinity till plus infinity. By this, as f itself is increasing, we know that they have the same sense of variation. Thus, f inverse will be from 0, from the limit 0 till plus infinity. And as you know, here we have limit as x tends to negative infinity, f tends to 0. This will be a horizontal asymptote for the curve of f inverse. Now, after this, we can draw easily the curve of f inverse, knowing the curve of f itself. We know the curve of f, which is the ln function. It increases from minus infinity till plus infinity in this behavior. This is x-axis, this y-axis. And this is, as you know, this function, ln function, cuts the x-axis at x equal 1. As we said before, the curves of f and f inverse are symmetric with respect to y equal x, which is the first bisector. This is the first bisector, y equal x. There is a symmetry between ln x and its inverse. This will act as a mirror. So we have 1, 0 belongs to the curve of ln, thus 0, 1 belongs to the curve of its inverse. And by this, we can deduce that its curve will be like, in a way that it is symmetric to this curve. Somehow, this is the f inverse, the curve of f inverse. Now, how could we get the explicit form of f inverse of the limit? The explicit form of f inverse. Well, as you know, we let or put y to be f inverse, and we need y in terms of x to get the expression of f inverse. In this case, in the case we have f is the lim. As you know, this equivalent to what? This is equivalent to say that x equal f of y. Go back and we know that f of x in this case is ln x in our case. So equivalent to say that x equal what? Ln y. And there is a rule to find y. Here we have to find y in terms of x. How could we get this? Can get this by a rule says that y equal e power x. If we have x equal ln y, we know this from previous chapter. If x equal ln y, then y will be e power x. Y equal e power x, but y from the beginning we know it's the inverse of f. So y, this is the expression of f inverse, which we call it an exponential function, which is the objective of this chapter. Okay? What is E? E is the note. It's a constant number, irrational number. It is approximated to 2.718, etc. It's called exponential constant in mathematics, and approximated 2.7. You can find it using calculator easily. After all of these informations about the inverse function of the ln, we can go directly to the definition of the exponential function. Definition. What is the exponential function? The exponential function, let's call it f, is the function defined by f of x equal e to exponent x. For this reason, we call it exponent function with base e, which is the exponential constant, and exponent or power, which is x in this case. Okay? Now, as we saw before, this is the curve of this inverse function. As you see, the domain of this function, the allowed values, the inputs of this function are from minus infinity till plus infinity. In fact, you can think about this algebraically. If we have a base e, let's say we have 10 power x, you can replace x by any value, any value, positive, negative, even 0. 10 power 0, 1, 10 power negative 1, it's also a real number, it exists in all cases. So similarly, e power x exists or defined for any values of x. X belongs to R, so df will be minus infinity plus infinity. Also we can recognize that e power 0 equal 1, and e power 1 is e itself, which is about 2.7. Now let's talk about some algebraic properties about exponential function. Calculation properties. As we deal with exponents in usually like مثلا 10 power let's say 2 times 10 power خلينا نقطش هو بلاوي شوي يكون عم غوص زياده بلاوي. طيب let's say we have let x prime belong to R, x prime are any two real numbers. The first property says that e power x times e power x prime, as you know, we have the same base. In algebra, we know that it will be x e power x plus x prime. Also, we have another property that says that e power to x minus y, it will be, sorry. The second property says that ex minus x prime, it will be ex over ex prime. In particular, e power minus x, it will be what? Like 10 power minus 2, it will be 1 over 10 power 2. So this will be e power 1 over e power x. Okay? Let's continue. The third property, which are quite simple, these properties, e power, let's say x to the power r, where r is a real number, then it will be what? We multiply here, we don't add, so it will be e power rx or xr as you like. Okay, these the calculation ones. Let's take some examples on these properties. Okay. Simplify. First example, let's say if we have 3x, e to 3x minus 2, we can split these as according to this property. I advise you in this case to pause this video and try yourself to do these examples and then play it back to check your answers. E power 3x over e power 2, which is e power x to the power 3, as this property says, over e squared. Okay? Easy, isn't it? Okay. The second example, if we have e power, let's say, minus 1, it will be 1 over e. Also simple. What about if we have, be careful about this, most students make a mistake in this. If we have e power x times e power x, it will be what? It will be, it's not e power x squared, it will be e power x plus x, which is e power 2x. You can do it, you can get this answer by another way. How? E power x times e power x, as you know, it will be e power x squared. Going back to property 3, you will get easily e power 2x or x times 2. It's preferable to write e power 2x. That's it. You get the same answer. The next title will be about the equations and inequalities. Dealing with exponential functions, it's good to work well on these equations and inequalities in order to solve equations, to solve the derivative of the inverse, the exponential function. Well, if we have, let's say we have a, b belong to r, and first property, if we have e power a equals e power b, this is equivalent to say what? A equal b, simply. Second property says that if we have e power a less than e power b for any a and b, any real number, we can easily deduce that a less than b. The third property, similar to this, if we have e power a, e to b, this is equivalent to say that a greater than b. The last one, which is the very important one, is if we have e power x equal, let's say, any constant number, but this number must be what? must be positive. Why it is positive? As you know, the graph of Ex, we saw that Ex is always above the x-axis. So Ex is positive for any x belongs to R. So this is equivalent to say what? If we need x and we know R, this leads to x equal ln R. Okay? Let's see some examples on these properties. Examples, direct examples. The question is solve. I will give you 3 examples on equations and 3 examples on inequalities. Again, I advise you to rewrite these exercises down and try to yourself to do it. 1, if we have Ex equal, let's say 2, simply as this property, we have x equal ln 2. That's it. This is the solution of this equation. Another example, if we have e power x squared, let's say, equal 9. Again, similar to this, we can deduce that x squared will be ln 9, which is a constant number. So this gives 2 answers: x equal square root of ln 9, or x will be minus square root of ln 9. These are the answers or the solutions of this equation. Third case, if we have, I will give you a more complicated case. If we have Ex plus 3e negative x equal, let's say, 4. How could we solve this equation? We need to find the value or the values, possible values of x. As you see, you may put e power minus x, you may write it 1 over ex and you make same denominator, or I prefer to do it by another way, just multiply both sides by, in order to remove this e power minus x, we multiply by e power x. Everywhere, this term, and that term. Here, and there. To get e power, ex times ex, as we said before, it will be e power ex squared plus 3 e minus x times ex, it will be e power 0, which is 1, equal 4ex. Again, arranging this equation by taking all the terms to the left side, you'll get ex squared plus, or simply, or minus 4ex plus 3 equal to 0. As you see, in our hands we have an equation with ex variable square minus 4, this variable, plus a constant. This reminds us by what? This reminds us by, yes, a quadratic equation. If we let ex equal t, then this equation has another form, which is t squared minus 4t plus 3 equals 0, which is quite simple, and you can, as you know, solve it using a calculator. By calculator, you can easily get t equal what, 1, or t equal 3. What condition do we have on t? As we know, as we have said there, ex should be positive since it's curved above the x-axis, so t must be positive, okay? In case we got t which is negative, then we can say that the equation has no solution. Now, we can find if t equal 1 and ex equal t, then ex, it will be 1 in this case, so x equal what? Ln 1, which is 0. Or, this is the first solution. The second solution will be, if t equal 3 and ex equal t, as you know, ex equal 3, so x equal what? Ln 3. That's it. These are the solutions, in fact, of the initial equation, this equation or that equation, which are equivalent to each other. The first example is e power x less than 3. We want to solve this inequality. As you know, x will be less than ln 3. We deal with it as we deal with equations. This is the solution. This means that x belongs to minus infinity, ln 3, excluded, since x is less than 3, and from the beginning we know that x belongs to R. With this condition we get the value of x, values of x. Sorry. Part 2. What if we have ex, let's say, less than or equal minus 4? What do you notice in this case? First, don't miss that. Ex is always positive value. Positive value. How can we get positive value less than or equal negative, which is impossible? So just say impossible. In this case, no solution for this equation, inequality, sorry. 3. What if we have e power minus x, let's say, less than 5? No problem if we have the exponent of negative values, as you know. This is a positive less than 5. Yes, it's possible. So, to deal with it, as we have done here, so minus x will be less than what? Ln 5, yes. But we need x, so multiply both sides by minus 1 to get x. Don't miss to reverse this, which is greater than minus ln 5. Implies that x belongs to R as from the beginning, and x with this condition greater than minus ln 5, then x will be over this, belongs to this interval. Greater than minus ln 5 till plus infinity. That's it.